So I've built this ground mount DIY plug-in solar system here using 4 Solar 460 watt panels and an EcoFlow Stream 800 watt microinverter. And following my last video, many wanted to know more about the frame and how I built it and what materials I've used, including how I've mounted the panels. So that's what I'm going to cover in this video, and there's timestamps along the bottom of the screen to allow you to jump to the relevant section, because this will probably end up being quite a long video. So first off, these panels, as I said, they're JA Solar 460 watt panels. These cost me £96 each from City Plumbing. They are 1.1 meters wide by 1.7 meters tall. And as you can see, these aren't bifacial panels, which I thought I was actually getting, but I cocked up with that one. I was looking at so many different panels online, and there were bifacial panels which were considerably cheaper than these. I was hoping to buy some at about £55 each, but then they came with a large delivery charge of about £150, which then made the panels quite expensive. So I ended up buying these ones from City Plumbing because I could collect from the local store and didn't incur a delivery charge. But I thought I was getting bifacial panels, but it turned out, my mistake, these ones aren't. The EcoFlow inverter is an 800 watt one, so complies with plug-in solar rules. So you've got a maximum of 800 watts coming out of it on the mains cable there. I have joined that with this waterproof junction box here to a longer flex that goes to the property. But this has two solar inputs. So I have got two panels wired in parallel on one input, and then the other two panels wired in parallel on this input. And I'll cover how I did that and the wiring needed a bit later on in the video. But for now, let's concentrate on the frame that I built. So the first thing you will notice is they are at a very steep angle, and I've mounted the panels at 55 degrees for maximum winter generation. And that's because I've massively over panelled this for an 800 watt inverter, and that's also why I've mounted the panels like this, and they're not facing south. So that set is facing southeast, so we'll pick up the early morning sun, and this set is facing southwest, so we'll get more sun in the later afternoon and evening. And that's because 460 watt panels is easily going to achieve that 800 watt limitation on the inverter. So I don't need to worry about midday peak sun. This setup is all about getting as most as I can out of that inverter during low sun times and during those winter months. And I used AI to help me with the angle of the panels, and it was saying that ideally for maximum summer generation you want them something like 30 degrees, but because of the over paneling here I wasn't really interested in that. I was trying to get the most out of these as I can in the winter, so it said mount them at 55 degrees, and fortunately 55 degrees was the steepest angle I could cut on the miter saw, so that's what I've cut them at. These are nowhere near the perfect frames. Ideally I wanted to make that angle there adjustable, but it was making my head hurt, so I just wanted to knock up something cheap, quick and simple, and I think for that they worked just fine. I also wanted to keep them sitting on the grass, so I didn't want to mount them into the ground and use any concrete, because I wanted to move these and play around with the angles, because I might actually make them more east and more west as well. I also wanted to keep them off the ground here, so that gap was intended to be tall enough or big enough to get the lawnmower under as well. So the whole purpose of these is I split them to two pairs just so that is movable and two people can lift that. You would have to disconnect the cables to move them, but anyway, the whole point was they were meant to be movable. I can play around with the angles that way. In the future I may well make them adjustable. I may rebuild the frames and make the angle adjustable, but for my first attempt it seems to be working okay. This channel has had over 15 million views, yet only has 40,000 subscribers, whereas it should be 3 to 4 times that, because over 90% of the viewers are not subscribed. Please do, it's completely free, it's only a click for you and it really does help. All the timber I bought from Wicks, and it's all treated timber. The posts are 75 by 75 millimeters. I'll put a drawing up of the dimensions of these frames, but one post length would do a longer back post and a shorter front post. This timber is 45 by 95 millimeters, and to be honest, it's a bit of an overkill, doesn't need to be that big. This timber is 45 by 70, and if I was to build them again, that's the only timber I would buy. I would do all the other bits in that smaller 45 by 70. I did make the mistake and buy too much of that because I thought I would need to put cross pieces as well, but the Strut is giving the strength that way, so I've just got a angled piece on either end, and then you can see where I've got the supports at the bottom, and that's strong enough. The Strut is what is joining the two ends together at the top anyway, and then this cross piece is joining the legs together at the bottom, and it's plenty strong enough. So let's show you the dimensions of this frame so you can cut the timber if you want to copy me, of course. My frame isn't the best by far. So the front posts, they're 75 millimeter square posts, and I wanted them to be 500 millimeters to give me that clearance to get the lawnmower at the front. So they're 500 on the back, and then you've got a 55-degree angle at the top, which makes it 396 on the front. And then we've got the supporting bit of timber here, and this was 1.2 meters. So the back leg then worked out to be 1379 or 1380. I don't know what this dimension here was, but this is the longer length, 1379, the longer length, 196, the shorter length here. So this gave you the outer, which then allowed you to work out the dimension of this cross piece, which goes to the outer edges here. And this is 688. I had to use AI to work out this maths. I think use sine for this. Anyway, it was too complicated for me to work out this, because obviously this 1.2 meters here is at a 55-degree angle. So based on that, we've got a frame which looks a bit like this, very roughly. So this is 1.8 meters to the outside edges. And then here we've got the Strut going across. So the Strut I cut at 2364. So this allows for your two panels, your gap in the middle of 16 millimeters. So let's draw the panels. So we've got two panels side by side. So they are 1134 each. I've got a 16 millimeter gap to allow that T-clamp in the middle, and then I've allowed for 20 millimeters either end for the end clamp and a little bit of a gap. Actually, you could reduce that, but anyway, that made these two rails here 2364 millimeters long. I would just add here that's 20 millimeters for the end clamp, and then another 20 millimeters of rail left. So that's the total, but you could possibly take 10 to 15 millimeters off this if you want to reduce how much rail is sticking out on the ends. For mounting the panels, I used electrician's strut channel. This is often called Strut. This is cheaper and easier to mount to the timber frame than using dedicated aluminium solar rails. I purchased this from Superlect Direct as they were the cheapest I could find, and they stock the hot dipped galvanized versions, which local suppliers didn't. The strut channelling I bought is the larger 41 by 41 millimeters. You can get this in two thicknesses of steel. This is the thicker one at 2.5 millimeters, and it's hot dip galvanized. Then I had to cut the struts down to 2,364 millimeters, so 2.3 meters, and this is nice and strong, so it will support the weight, that will not buckle, and you don't need to have a central brace. If I was to do this again, I'd probably get the cheaper 41 by 21 millimeter version, as I'm sure this would be strong enough. So when it comes to the clamps to mount the solar panels to the rails, I bought the hardware from City Plumbing, and these are for 30 millimeter deep panels. So I have a pair of this type in the middle of each pair, and then a sort of S-shape end clamp, and then there's 4 of those per frame. All of these solar panel clamps came with these aluminium nuts, but they're designed for the aluminium solar rails, and they're no good for Unistrut. So you need to buy some larger Unistrut nuts, and I bought these from Superlac. They're very cheap. However, I cocked up with this because I took one look at these bolts and thought they were M6, so I bought the M6 nuts, but these are M8. So I then had to buy some M8 nuts, and I bought these locally from TLC Direct, and as you can see, these have got the yellow plastic rings on them because they lock themselves into the rail a bit better, so you don't have to sort of get your fingers behind there and hold the nut in place when you do the bolts up. For the screws, I bought these exterior grade green screws from Wix, 5 by 75 millimeters. That's all you need. I also bought some 5 by 90, thinking I'd need them for the diagonals, but didn't really use them. So one box of those 50 pack is all you're going to need. I've put a coach bolt through where each cross piece is joining the leg, just to give it a bit more strength, because there is quite a bit of weight on these. These panels are 20 kilograms each, so with the Unistrut that's probably 45 kilos. So rather than just relying on the screws, these coach bolts were nice and cheap as well, and they just clamp it all together and give it a bit of strength that way. For fixing the Unistrut down, I bought these screws from Screwfix, turbo coat screws, 8 times 40 millimeters, and they're self-cutting screws like that, with some M8 penny washers on the heads like that. And the strut is screwed down to the timber with 2 screws at each end. So I thought I'd mount the inverter underneath the solar panels, because this is going to be sheltered by a panel, so it will keep it dry. These are waterproof anyway, so it doesn't matter, and it keeps all of the MC4 cables shorter, and then you just run the mains cable back to the property. And apparently these can get quite hot, so I've mounted it like this so there's plenty of airflow, and it can get air to the back of it as well. So my EcoFlow inverter only came with one cable in a separate box, this one. So this is the mains cable, so you've got a waterproof connector there which plugs into the cord that comes out of the inverter, and then you've got an unmade end, this end, which you would put your 3-pin mains plug on. But this isn't long enough. I think this is 5 meters, but it's not long enough for me. So I've got some 2.5 millimeter square cable, which is a bit of an overkill, but I'm going to extend that. Well, I've actually got to cut this off very short, and I've got a waterproof junction box here which I'm going to mount on the solar frame, and then run this cable underground in some conduit back to the property. And I was going to hardwire it in on a fuse spur, but I think I'm just going to put a plug on the end, and then this gives you effectively an off switch, so you can pull it out if you need to. And you just need a 5 amp fuse in your plug, because this is only going to be running at 800 watt maximum, which is 3 amp. And because the inverter didn't come with any cables, you need to buy a load of extension cables. These are MC4 extension cables. So when it comes to the wiring, I wired each pair in parallel, as I said, and I did that using these Y branch MC4 adapters. So you've got 2 inputs on one side and 1 output, so it's just wiring those in parallel. I bought these on eBay for about £5 a pair, something like that. And you can either buy adapters like this or Y branch cables. I decided on the adapter because I think they're going to be a little bit more robust and less connections. So we've got the negative from one panel going into here and the negative from the other panel going into here. So you've got one negative output going to the inverter there, and then you've got the same with the two positives going into this adapter and the one positive cable going off to the inverter. So these are all in 4mm cables on this side, and then on this side I've got 6mm square cables. But I have had to use an extension cable to get that far side to reach over to the adapter. That's a 1 meter extension cable in 4mm square wiring. And then I'm using two 4-meter extension cables to go from this side of the adapter, and this is in the 6mm square wiring, to get it all the way around here down to the inverter. And then obviously the same setup for this panel, using the branch adapters here and here, but then only using 1 meter patch cables to get them over to the inverter there. And then I've earthed the panels by scratching the paint off the earth points on the frame using some M4 bolts. It was cheaper to buy those on Amazon. I'll put the link in the video description below. I've then used some earthing cable I already had. It's a bit too thick for this job, but anyway, I had it, so I didn't want to spend any more money. So that's linking all the frames together. And I've connected that into the junction box here, picking up the earth from the supply cable. Then I've just used some braiding and some cable ties to tidy it all up. But it's not yet finished yet, because I need to bury this mains cable in the ground in some conduit. But I'll do that when I know I've got these frames in the right location and I've looked at all the possible shadowing. And as to how these panels are performing and the generation I'm getting, I'll keep that for another video. I think for this video I'll just keep it to the frame design, the materials I've used, and I'm going to link everything in the video description below. So I hope you found this video useful. If you have, please do click the thumbs up, that really does help, and I'll see you on the next one. If you like the video, please do click the thumbs up button, and leaving a comment also helps too. Plus, of course, subscribe if you're not. If the video saved you time or money, a little support via Ko-fi or the Super Thanks button would mean a lot. There's over 1,300 videos on the channel, so have a browse, use the search, and have a look at the playlists. And here's 2 videos you may want to check out.